now we move into a section where we have to, that we get when we solve quadratics, and sometimes we have a negative number under the square root. And up to this point, we've had no ability to deal with this. And if you punch a negative square root into your calculator, some of you may realize it gives you an error that says no real solution. And what that's implying to you is that there's actually no real number solution. That does not mean that it doesn't exist. What it's trying to tell you is that the solution to the quadratic is actually in a different number system that we haven't learned yet, called complex numbers. So that's going to be the focus of this lesson. Now we're going to break this lesson up into a couple different videos so that you can see the different type of operations as we go through. What we're going to focus on first is dealing with solving quadratics using square roots, just like we've done in previous lessons. But now we're going to run into the situation where there's a negative value under the square root. And so we're going to work on dealing with that situation first. Before we can actually get into solving quadratics, we need to define a few things and make sure that you are very clear on some terms and some equations here that are very important. So if you thought about it, where you had to square a number, there is no number that you can square and get a negative value. And so what happens is that's why we don't have a real number solution when we have a negative value under the square root. So we developed this system of complex numbers which uses what's called the imaginary unit. And we call that imaginary unit I. Now, I has a definition of square root of -1, and of course if we squared both sides, that would also be I squared equals to -1. Now these two highlighted things are extremely important. You must know I equals the square root of -1 and I squared equals to -1. Both of those are going to have some very important places in the problems that we're going to work, and you're going to need to recognize when you can substitute those things into a problem so that you can continue to work. Now, I'm going to take this concept and I want to show it to you in some other examples before I move into solving a quadratic. So I'm just going to move to another document here real quick. I've got some other problems set up. Now let's just take a look at some simplification problems to start. So we can say that we want to simplify, and in this case we would want to simplify the radicals to simplest radical form. Now if you recall from the square root of 8, and we've done the problem like this before, that actually breaks up into the square root of 4 times the square root of 2. And we were looking to pull out the perfect square out of the square root of 8, which was 4. So we're going to do this. We're going to be left with 2 times square root of 2. And of course, if we were in the process of solving a quadratic, we would need both solutions, so that would require the plus or the minus sign. So that was your standard simplifying of radicals before. Now we can run into a situation where we can have a square root of -8. And as you've seen, if you punch this into your calculator, it tells you error, no real solutions. Now, this is where the concept of I equaling to the square root of -1 is going to be a big help to us in solving or simplifying this particular radical. So now when we break this radical apart, we can break it into 3 different parts. We can break it into square root of -1, square root of 4, and square root of 2. What this is going to give us is -8, square root of -8 if we were to multiply these back together. Now, the square root of -1 in terms of definition is just simply I. Square root of 4 is 2, and then the square root of -2 stays the same. Now, from a mechanics standpoint, we need to write this in the proper order, and it's just like IX, just like a variable x would. We would never put the x in front of the 2. We would put it behind the 2, but we want to put both the the coefficient and the variable in front of the radical. So we would actually write this as 2i times the square root of 2. And of course, if we were solving a quadratic here, we would need both solutions. So it's actually plus or minus 2i square root of 2. So that is just a simple example of how the imaginary unit, I, can be used to help us simplify radicals. And if you remember in solving quadratics using square roots, simplifying radicals was a very important part of that process. Now let's move into a different example that we saw when we were factoring. In this particular case, we could do one of two things. We could either simply factor the x squared minus 4 into two parts and get the values necessary, or we could move the 4 over to the right side and come up with that. So if I just took it from a square root standpoint, I would get something that looks like this, and then of course we would get x equals plus or minus the square root of 4, which we know is plus or minus 2, and that would simply be our answer. Now, we also remember that this value could be the replacement value of y. So these are actually our x-intercepts. So our x-intercepts in this case would be 2, 0, and negative 2, 0. Now, remember, if you recall, you can actually factor x squared minus 4. That's a difference of squares. And that's x plus 2, x minus 2. And we said if it's factorable, then we would have a clear-cut x-intercept values, and that's where the relationship is there. However, if you look at the problem to the side of it, x squared plus 4, if you recall, we told you, or we should have seen through practicing these types of problems, that x squared plus 4 actually does not factor. So you cannot factor this problem. And as you'll see as we work this, if we were to work it using square roots, because we cannot use factoring, we're going to get x squared equals a negative 4, and then we're going to get x equals to plus or minus the square root of negative 4. Now, we're going to need to use our simplification again, but here, in this particular case, we're actually going to have the square root of negative 1, and now the square root of 4. So we can get x equals to plus or minus I times 2, and the appropriate way of writing this would be plus or minus 2i. And so those would be our two solutions to this particular quadratic equation using square roots. And so you can see where having I equals to the square root of negative 1 is very helpful in simplifying this. Now here's where the other problem comes in. If I'm looking at this, that is supposed to represent y. So the x-intercepts in this case are two imaginary values. So in reality, what this is trying to tell me is if I cannot factor, then I'm probably going to end up with some imaginary solutions, which means that there are no x-intercepts. So this is going to be an important concept for you to hold on to and understand the relationship between real solutions, which these would count as real solutions, and this is what we would call an imaginary solution, or two imaginary solutions. So you can see the relationship between real solutions and x-intercepts and factoring. And then there's a relationship between imaginary solutions, x-intercepts, and factoring. And so you would need to kind of understand the way that works. So if I take this down a little further and I write it as a function, so I'm going to take the same two problems, and notice I've written it as a function, and so we're asking you to graph these. So if you look at previously, all the way up, this was just a simplification problem. Then in this particular area, we ask you to solve. And then lastly, we want you to graph. So let's take a look at the graphing of these two problems. If I go to my calculator and I press in x squared minus 4. Now we know we can factor x squared minus 4 because it's a difference of squares. And so what that should tell us is that there actually will be two x-intercepts here, which tells me that there are two real solutions. And in this case, we can see by looking at the problem that it crosses the x-axis at +2 and -2, and those are our real solutions to this problem. However, on the other problem, x squared plus 4, we realize that we cannot factor x squared plus 4, and so there's a relationship there. Since we're not able to factor this cleanly, there will not be any x-intercepts, and the solutions would then be imaginary. So if I were to graph this in on the same graph, x squared in this case plus 4, you'll see that x squared plus 4 actually does not cross the x-intercept. So the solutions to this, since there are no x-intercepts, it does not cross the x-axis, there are no x-intercepts, so these solutions would be considered imaginary. There still are two solutions to this problem. We're just going to have to work it a different way other than factoring, and we have no visual way through the graphing to see the two solutions. So this is where understanding imaginary numbers and working them in a different way other than factoring or graphing will be important in coming up with your solutions to your quadratic equation. So this is just a couple examples that wanted to show you to kind of introduce you to the understanding of an imaginary number. Now let's go back to our notes here and take a look at this. So that was a good use of I equals to the square root of -1. As we go through further in the notes, and probably in a later video, we'll discuss where I squared equals to -1 comes into play or becomes important. But let's take a look at another sample problem here. So if we look at example 1, we can see we have 3x squared plus 10 equals to -26. Now, you could try to move everything to the left side and get 0 and then go through your factoring method, but I think you'll realize after doing that a couple times that factoring would not work out for you here. So our goal in that case is, if we choose not to factor, then we want to isolate the x squared value. And so we'll go through our steps until we can isolate this x squared value, and we notice that it's equal to a -12. Well, before that would have been a problem because we wouldn't have been able to get any solutions out of the square root of -12. But now that we know the square root of -1 equals the imaginary unit, we can simply break this radical down into its individual parts and come out with an I value. And remember, since we are solving quadratics in this case, we do need a plus or negative value. And in this case, we have the plus or minus 2i times the square root of 3. And keep in mind, the I value acts just like a variable as far as where it goes in the structure of the written answer. So it goes behind the coefficient, and of course the radical comes last. Now this would be considered an exact value. We are not putting this into our calculator to get a decimal because the decimal does not work with the imaginary unit. So we have to keep this in simplified radical form. So using example 1 as a guide, let's go ahead and pause the video at this point and look at sample problem 1. You have a part A and a part B. So go ahead and pause the video and work sample problem 1, part A and part B. Okay, so if you work these two examples similar to example 1 before, let's see what you come up with. Remember, the first thing that we're attempting to do is to isolate the x squared term. So first we'll subtract 26 from both sides, which will give us a -36. Now at this point, we can't use the square roots yet because if we take the square root of 2x squared, 2 is not going to give us a perfect square. So we need to eliminate the 2 from both sides by dividing it, which is going to give us x squared equals to -18. Now we're at a point where we can take the square root of both sides, and we'll get x equals to a plus or minus square root of -18. Now, this is just a simplifying radicals problem at this point, except that we have a negative value in there. So we need to take the negative square root of -1 out of there so that we can get the imaginary unit. And of course, this is going to equal to plus or minus the square root of -1 times the square root of 9 times the square root of 2. And x is going to equal to plus or minus I times 3 times the square root of 2. And I would want to write this in the appropriate way. So plus or minus 3i times the square root of 2 would be our final two solutions. So that is the final answer to part A. And it's no different than solving any other quadratic problem using square roots, except that now we have an imaginary unit as part of our answer. Okay, so let's look at part B. In part B, and if you don't mind, I'm going to erase this part from sample problem 1 part A, so I have room to work part B. Now for part B, we're going to do the same thing. We're going to try to isolate the x squared value. So I'm going to have 5x squared equals to -10. Again, we can't take the square root of 5, so we have to divide that out. So x squared equals -2. Now we can take the square roots of both sides, and we're going to get the square root of -2. And this is simply going to lead us to plus or minus I times the square root of 2. And of course we broke this up into the square root of 1 times the square root of 2. And the square root of -1, is I. So that would simply be the way that you would work a quadratic equation with square roots. So this is an extension from our previous lessons, but now we have the imaginary unit as part of our answer. So be sure to get lots of practice working problems like this. You will need to identify this as you work different quadratic equations and understanding when you'll have an imaginary solution and when you will not.